Hi, I'm James the Light Guy, and today we're taking a look at electroluminescent tape. This is EL tape. There's also EL wires and EL panels. They all function under the same principle and are a fun little technology. So, starting with the basics. These tapes actually run on alternating current rather than direct current. How they work is we have two leads. If I pull this off here and zoom in, you can see that our positive and negative go onto each side of this tape. Between the two is a film of phosphorus and other elements. As the alternating current gets pushed back and forth through this phosphor compound, it excites the electrons, and as they drop down to their original state, that energy has to be released somehow, and it gets emitted as a photon beam. Depending on what other elements are mixed in with the phosphorus, you get a different color. This white looking tape is I believe they called it Aqua, and this blue one is, well, blue. Let's talk about this power supply. So I got this from glowcity.com. It's a cheap 9-volt power supply. You put a standard 9-volt battery in it, and I'm not going to take this one apart, but I have one taken apart already. Give me just a sec. Here we have the smaller version. Instead of a 9-volt battery, this one ran on 2 AA's. However, I was messing around and tried to see how much current I could push through it, and I melted a winding. So if we pull this out, we can see that it is really incredibly simple. We have a couple of micro switches and some resistors and a large transformer. Well, relatively large. It's honestly quite tiny, as well as an on-off and function switch. Depending on which one of these capacitors still has a charge, when you click this, it will send this through either a strobe on, solid on, or off. So, fairly simple. This is the same thing. In fact, you can see the windings through that little cutout and this hot glue. Just a slightly beefier version. This one gives you a brightness control and a speed of the pulse using small potentiometers, which is a neat little feature. First thing we're going to do is we're going to install this battery in and hook it up to one of these tapes. Now, all of these EL wires have a standard connection, the EL wire, EL tape, and EL panel. But depending on their size, they have different amperages that are required to illuminate them. So we are now going to try and power a 1 meter strip of the Aqua with this 9-volt battery. There you can see it's on flash mode. Let's get that on solid and put it to full brightness. Now, as you can see with the studio lights, it's not super bright. Let's turn off the studio lights. And you can see it's quite a bit prettier. I still have some background lights, but you get the idea. This is the Aqua Blue. If we disconnect that, and I'm going to bring this meter up to the microphone, there is a high-pitched noise. You're really not supposed to leave that on with nothing connected to it. So that was silly of me, but all for the sake of science. Let's connect up our blue tape and power this back on. You can see it's in its blink mode and now solid. This one is a little bit brighter and a richer blue. Let's go through the controls here with our brightness control first. We can go to completely off and work our way up to full brightness and switch it to flash. And this is currently the slowest flash mode. We can speed up that by pushing this wheel upward and upward more until it becomes a crazy strobe light. Pretty cool stuff. Next, what we're going to do is quickly just test what the current output of one of these 9-volt batteries is. We have our new multimeter, orange and black to match everything else. Of course it is. We're just going to set that to amps measuring. Set it to DC and set the range there. Hook up our probes and you can see about 200 milliamps. Now, on this box power supply, it has a 9-volt 300 milliamp power input. So let's hook up our power supply to it and see what one of these lights draws. We now have our power supply wires connected up to the battery terminals here, and we'll turn on our power supply, currently set to 9 volts. Let's take that down just a tiny bit. There we go, 9 volts. And we have our amperage set to virtually unlimited. Let's see if we don't fry this thing. Turning it on at minimum brightness and flash. Currently, we are hooked up to this one, and you can see that there is no change in current draw. Let's go to full on and ramp up the brightness. Still nothing. Oh, I'm silly. I put the terminals on backward. Clearly, that wouldn't work. Let's spin those around. Let's see if I can actually get them to stay attached. Stay attached. One more time. Stay attached. You'd think I would edit this out, but I'm not going to. I like you when you guys can see me fail at the simplest of tasks. There we go. All right. Power on, and work up the brightness. You can see that we are starting to draw some more current, and we're starting to illuminate. Whoops, popped off one more time. And let's work it up to full brightness. You can hear the whine going. That's max brightness, full on, no strobe, and we are drawing 125 milliamps. Let's see if I pull off my microphone. If you guys can hear that whine, it's actually really subtle to the human ear, so maybe the microphone will do a better job at picking it up, maybe it won't. So, let's talk about a couple of applications for these. They look great in the interior of cars, and by being able to put an AC to DC power supply in through the side, you could wire them up in like a kid's bedroom up on the wall. They draw so little power over the course of this entire surface that they will never overheat. However, they are not weatherproof. The wires are just soldered onto the ends and protected by a little bit of heat shrink here. which would eventually corrode if not properly sealed. My plan is to use these in a running application. I'm going to cut this in half, or possibly use this one since it already has terminals soldered on each end, and wire them up to a portable power supply like this, and then use some sort of double-sided hook and loop tape to attach it to my running clothes to wear at night to be more visible to oncoming traffic. And with the pulse adjustment and brightness adjustment, I can attempt to make myself as obnoxious as possible. That's actually all I have for today's video. If you enjoyed it or found any of the information useful, go ahead and hit that like button for me. Consider subscribing to the channel if you haven't done so already, and maybe share with your friends. Until next time, I'm James the Light Guy.